Thank you for responding for the consent for the recording, and we will start. So as a review, so last time we started with the routing protocol. So in routing technology, so there are things that we need to define. So first, we discuss router interfaces, routing tables, and now we are on routing protocols and access control lists. So, so here are some of the diagrams last time on how router able to and we have browsing technologies. So the terms we use, destination network, next hop, and metric, and on how the route derived and the timestamp. So timestamp is tells the router how long it has been since routing protocol updated the dynamic route. So not all routing protocols requires timestamp. So for the lecture today, so we will continue on the open short path first. This is a link state protocol that was developed for IP networks. So it's based on a short path first algorithm, but it's going to maintain an identical link state database that describes the topology of the area, and each router or system in the area generates its link state database from the link state advertisements. So these are LSAs, and LSA is a packet that contains information about neighbors and path costs. So based on link state database, each router or system calculates a short path spanning tree, and itself is a route using SPF algorithm. So this is your short path first algorithm, that is SPF. So what are the advantages of OSPF compared to other protocol? So routing information protocol, or RIP, is more on distance vector, and while OSPF is more suitable for serving large heterogeneous internetwork. So when you say heterogeneous, it's mean diverse, or there are only specific department that you're going to implement this, and you could also apply to other. It's easy for network migration. Or OSPF can recalculate the routes in a short amount of time when the network topology changes. With OSPF, you can divide an autonomous system into areas and keep area topologies separate to decrease OSPF routing traffic and the size of the link state database of each area. So OSPF provides equal cost multipath routing, so you can add duplicate routes to the TCP stack, and using different next hops. So there's also a method we use normally is the hello protocol and the link state database exchange. So after routers or system in the OSPF ensure that their interfaces are functional, so they first send out hello packets. So what do you think are hello packets? So this hello packets allows you to communicate with neighbors, and neighbors are routers or systems that have interfaces to the common network. So after that, neighboring routers or system exchange their link state database to establish adjacencies. So the following figure demonstrate the process of discovering neighbors and establishing connections between two systems. So we have next. So in this way, even if you are not connected with a network, but could be able to have exchange information. Example. So first we have system A and system B. So the sequence would be you will be identified as 1.1.1.1.1, and after that there will be initialization, and once you see the name, so you will have to have the dynamic the range. So the next would be exchange start. This would allow you to message the other computer that you will start. And for exchange, you could now try to transfer data. Now for loading, you are now going to request a link, and this time now you are going to have full operational system, because in this way you will discover that there are how many neighbors do you have. So you have 4, but initially you could not find the other computer, but with the open short path first, you could discover neighbors around your system. And with this, you could exchange information as well as send exchange data and also load data between these two computers. So using router, so you could do this by sequence. It depends on how you implement it. Now, first, how do we start? So you have X start phase. So when you say X start phase, so this phase allows you to negotiate who is the master and who is the subordinate. So when you say subordinate, you are like your leader is the master and you are the team members. So you establish the group of the bits here at X start. Exchange. So there are two system exchange database description to find out the LSAs that is the link state address or algorithm that the link state database of each system does not include. So each system stores the LSA that are not included in the database. And if you're not included, you will going to be retransmitted, and again you will be checked. So if you are there, so you will be included in the database in the exchange phase. So there will be retransmission if you are not included in the link state database. So in order for you to send the information, you must be in the link state database. So after the exchange phase, so now we go to the loading phase. So loading phase, so which means that each system sends link state request packets to the neighbor or other system, for example, and send it to the entire LSA that were stored in the retransmission during the exchange phase. So when the neighbor responds the request, so this is what we call the link state update. So now, so it's like in the neighborhood, for example, in one block. So for example, there is a new new family going in the block. So if the neighbor is going to have this block party, so there will be people going to exchange or greet this neighbor, and you're going to exchange numbers and everything else. Information will be updated, and all the neighbors are now know that you all stay there in the block. So this is like one line that all of you introduce a certain computer to the new system. So if the computer is new, so you need first to have include the computer in the database. Then after it is being included in the database, so Exchange allows you to update the database and update all the computer that this is the new computer that is included in the system. So that's the purpose of loading phase. So it updates the link state packets. Now, if you are finishing all the update of the new computers, the neighbors, it's included already in the link state update, and also was in the database in the exchange phase. So, and also the last step would be the full phase. So when the two systems finish exchanging LSAs and their link state database are synchronized, adjacency is established between two systems. And now, so this is how Open Short Path First protocol establish adjacency in routers and system in the area, so that you're not going to be surprised that when you go to the park, that when you are new, it takes time for you to be included in the system because the system will update their database and will load your IP address, and you become a subordinate. So the master would be the system A, and you are the subordinate, the computers inside the system. So that's how we deal with OSPF. Also, we have designated router and backup designated router in cases that the system fails. So if we have so much traffic, so only those computer who have included in the database will be considered. And if you're new, so it depends if you could be able to enter the link state address, and this allows you to use the backup designated router if there are too much congestion, and this allows multi-access networks. So and with this, same capacity will be introduced because we have term adjacencies, and all the other routers in the network are adjacent to the designated router. So this designated router decreases the network traffic and the size of the link state database for this network. Now, the backup designated router does not have any differences from other routers, except that it needs to establish adjacencies with all routers in the network, including the designated router. So a backup designated router is promoted to designated router when the current designated router fails. So that's why we have the backup designated router. So therefore, routers in this example, on the previous image, we have this example. So this example uses broadcast network, and the routers elect designated router and backup designated router using a hello protocol. So system A is designated as a router and system B as backup designated router. So this is system A, your designated router, and system B is your backup designated router. So if this fails, so you have another one who will take over the network congestion of the system A. Now, we have also this term. So this is another network diagram. So as you can see, you have this system B, and you have system D. So a router is located on the border of the OSPF areas and connects these areas to the backbone. So they are called area border router. So area border router has multiple interfaces to the multiple areas. They have a separate link state database for each area. Now, for example, we have figure 3. So this is figure 3. So we have area 1.1.1.1.1 and 2.2.2.2. So this is area 1 and area 2. These are configured, while system B is an area border router. So system B is the area border router. Why? Because it is located at the center and it is attached to 2.2.2.2, which has two link state database. So for each area, system B establishes adjacencies between system A and system router C. And this allows you to visualize how it was being implemented. So this is router C, this is system A, and this is system B. So also it establishes system D adjacency. And after OSPF, we go now to enhance interior gateway routing protocol. This is one of the two famous routing protocol in our network. So what is EIGRP? So it's an interior gateway protocol suited for many different topologies and media in a well-designed network. So scales well and provides extremely quick convenience times with minimal network traffic. So how does EIGRP or E-group perform? So it has very low usage of network resources during normal operation. And when a change occurs, only routing table changes and are propagated, not the entire routing table. There is a rapid convergence or changes in the network topology. So when you say converge, there is a migration. And also, EIGRP is an enhanced distance vector protocol that is relying on the diffused update algorithm to calculate the shortest path to a destination within a network. So what are the major revisions of the protocol? So there are two major revisions of the protocol. We have version 0 and version 1. So normally Cisco iOS version are 10.3. And some explanation are not applied to other versions. So includes mainly performance and stability enhancement. So what's the basic theory? So a typical distance vector protocol saves the following information when computing the best path to a destination. So instead of establishing network, it calculates the distance on how many connection you want to have. Example, you have one, two, three. So you have three distance. So hop count, you have three hop count and the vector. Next hop, for instance, all routers in the network figure 3 are running in routing information protocol or RIP. So the router 2 chooses the path to network A, and by examining the hop count through each available path. So since the path through router 3 is 3 hops, as I mentioned, so the path to router 1 is 2 hops, and the path to router 2 chooses the path through 1 and discards the information it learned through 3. So this one, from here, from 3, you have 3 hops. From 2, you have 2 hops. From network A, you have 2 hops in the second router. And so this allows querying neighbors also. But router 2 saves the information and received from router 1 and 3. So it chooses the path through 1 at its best path or the successor. So it depends on how you set up, but in this scenario, the shortest path is near considering 2, which allows you to communicate with 1 and 3 and makes the path only 2 hops to go to network A. So with this brief explanation, so EIGRP must provide a system where it sends only updates needed at a given time. So this is accomplished through neighbor discovery and maintenance, and a way of determining which path router has learned are loop-free, a process to clear bad routes from the topology tables of all routers on the network, a process of querying neighbors to find paths to lost destination. So that's why we use a ping to connect to another computer in order for us to search for better connection. Now, if you find it difficult to communicate with other computers, so you transfer your cable to another port and make sure that this is going to be the easiest path that you could take. So for the neighbor discovery maintenance, to distribute routing information throughout the network, EIGRP uses non-periodic incremental routing updates. So that is, only sends routing updates about the paths that have changed when those paths change. So the basic problem with the sending only routing updates is that you may not know when the path through a neighboring router is no longer available. So this is the problem of EIGRP, of the Enhanced Interior Gateway Routing Protocols. It doesn't give information which neighboring router is failing, and you cannot time out routes. So you are expecting to receive a new routing table from your neighbors, and the EIGRP relies on neighboring relationships to reliably propagate routing table changes. Throughout the network, two routers become neighbors when they see each other, hello packets on a common network, and EIGRP sends hello packets every 5 seconds or on high bandwidth links and every 60 seconds on low bandwidth multi-point links. So how do we have neighbor discovery and maintenance? So first we have 5-second hello. So this would allow us to broadcast media. We have point-to-point serial link, and also we have high bandwidth to use neighbor discovery. So that's why when you try to check your network, there's ample of time that you need to wait for the update of your network. And there is also a 60-second hello. Multi-point circuits or T1 bandwidth, or these are your UTP speeds, uses frame relay multi-point interfaces. And these interfaces having switch virtual circuits or ISDN BRIs. So some factors to consider when deciding to use routing protocol or static routes. What is static routes? So if you put default on your network, that is static. Or you want to put 192.168.1.1, that is static. But if you consider routing protocol, so how does the network change? So our networks going offline frequently. So if routing protocol is a good choice, if not, a static routes should be considered. So if you network change sometime and with new networks added, so routing protocol is a good choice. So there are also several alternate paths to many of the networks in the intern network. So if a routing protocol can reroute around links or congested routes automatically, but with the static routes, an administrator must change the routing table manually after the problem is discovered. So that's why we are going to have reset, exchange methods, because an administrator can change the routing table. So once the administrator change the routing table, so you will have a different IP address. And he will also reroute other IP address that is not usable. So if the internet network is large, so keeping up with the status of all networks may prove to be more work than you bargain, because on static routes, you're going to have it manually. But in routing protocol, it builds and maintain routing tables automatically, freeing you to do more important tasks. So we have now on the last three slides, I think. So we have the access control list. One of the advantage of routers in an internet network is that you can group users who need access to common resources into subnets. So a router facilitate user, so one subnet being able to access resources on another subnet. So it used to block access, and routers can use access control list to determine which network traffic passes through and which traffic doesn't. In a access control list, so these are a set of rules configured on a router interface for specifying which addresses and which protocols can pass through the interface and to which destination. So we call it packet filtering as a method in the access control list. ACLs are usually configured to filter traffic, and based on the following, we have inbound and outbound traffic, we have source address, destination address, and protocol address control links are ACLs. So for summary, in our lesson 6, routers are used to divide large networks into smaller broadcast domains, as well as used to create complex internetworks, so that local area network in a large international corporation. OSPF protocol is one of the family of IP routing protocols and is an interior gateway protocol for the internet. It is used to distribute IP routing information throughout a single autonomous system in an IP network. Also, we have enhanced or EIGRP. So it's used on a router to share routes with other routers within the same autonomous system. Unlike other well-known routing protocols such as RIP, EIGRP only sends incremental updates, reducing the workload on the router and the amount of data that needs to be transmitted. So I think we're done. And any questions in your lecture?